A person in a whispering gallery, standing at one focus of the ellipse, can whisper and be heard by a person standing at the other focus because all the sound waves that reach the ceiling are reflected to the other person. If a whispering gallery has a length of 272 meters and the foci are located 64 meters from the center, find the height of the ceiling at the center. So they have these in real life. I don't remember exactly where they have them in the United States, but there is such a thing. And actually, I just typed into my Google here their whispering gallery. There's one in New York, and there's was one in St. Paul's Cathedral in London, and there's one at the Grand Central Terminal in London as well. I assume that's in London. So they have them around the world. We have whispering galleries. And what that means is it's basically taking advantage of the ellipse shape. So if you're standing at one of these focus points and your friend is standing over here at the other focus point, what an ellipse, and then the ceiling is shaped exactly like an ellipse. Now there's different kinds of curvature. You'll get more into that if you go higher in math and science, especially in calculus. You'll talk about different kinds of curvature. So elliptical curvature works in such a way that if your friend's here and he whispers something, if you're standing here, your friend's standing here and you're standing here, your friend whispers, barely whispers something, it'll go up, bounce off the ceiling, the sound waves will, and it'll aim them right at the other focus point of the ellipse. That's what the focus points really are in an ellipse. They're where it focuses all the sound waves that bounce off the ceiling, or light waves, or any kind of waves. It goes from one focus point to the other. It focuses them, hence the name. And so anyway, if your friend stands here and barely whispers, you'll hear it way like 100, 200 feet away, as if your friend is inches from your ear. You'll hear the whisper right in your ear, even though your friend is hundreds of feet away, because it'll bounce off the ceiling, and every sound wave, it'll bounce off the ceilings, and they'll all these sound waves from your friend's sound will all bounce right to you and your ear if you're standing at the other focus point. So that's a whispering gallery, and so we want to find the height of the ceiling on this one. So let me draw basically what they're saying. We have, let me draw a little axis system here. Let me come down, or we'll do it right here. So we have an axis system, and they're telling us that we've got this elliptically shaped ceiling. It's just half an ellipse, a semi-ellipse. It's just the top half of an ellipse. And then there's these focus points. Now remember, the focus points are always not quite all the way to the edges. So these are the foci, the focus points. They're inside. And then let's put down the measurements. It says the whispering gallery has a length of 272. So if I take 272 and divide by 2 on my calculator, I get 136. So that means, right, that means the 272 is all the way to that edge and all the way to that edge. So then this must be right here. This must be 136 over, because that's half of 272. It's 136 each way. And then how far is it to the focus points? Well, it says the foci are located 64 meters from the center. So these are both 64 meters from the center. So the question is, how tall up here? What's the height of the ceiling at the center? So that's so we use our equations of ellipses. So it would be super hard to do this problem with just straight geometry or something. It would just be crazy hard. So instead, we're going to use the equation of ellipse. This is really an ellipse. It's half of an ellipse. We could bring the other half down here. It's an ellipse. So what's the equation of ellipse? Well, it's x squared over a squared plus y squared over b squared equals 1. Now, why don't I have like x minus 2 squared or something like that? Well, because I put the center at 0, 0. And I made it that way. I could have, do you see what I'm doing? Do you see how this is a great point in time to see how math works with the real world? Math is made up, completely made up, to help us deal with things in the real world. So the whispering galleries are part of the real world. And to figure out, the height of the ceiling, when they're designing this thing, they've got to figure out how tall to make the ceiling to make this shape work. You've got to use a made-up math equation, right? And you can put this ellipse anywhere you want, so why not put it right at the origin? That'll make my work easiest. So I put the ellipse centered at the origin, so I just have plain x squared and plain y squared. I don't have any x minus 2 or anything like that. The center is 0, 0. Now, what's the a and the b? Remember, whatever's under the a and b can be switched around, but whatever's underneath x is how far right and left from the center. What's that? 136. 136 is how far to the edge, right and left from the center. So this a squared is 136 squared. What's b squared? Well, that's how far up and down from the center. So in other words, that's how far up here. That's b, or I should say A is how far up and down, and A is how far right and left, B is how far up and down. So that's B, that's what I need to find. That's the height of the ceiling, right? So there really is no bottom in the ellipse. This is the ground right here, isn't it? And so that B is the height of the ceiling at the center. That's what they're asking me to find. That's what they really want. B, we need to find B. Okay. No, well, how am I going to find B? What can I do with this equation? Well, we have the focus. We know how far to the focus points. Right here. Focus point, it's 64. So that makes us think we should probably use the focus equation. Remember the focus equation. What's the focus equation? It's basically the Pythagorean theorem with a minus. Right? The real Pythagorean theorem has a plus. We're using the Pythagorean theorem with a minus. So use the Pythagorean theorem. We know a squared is 136 squared. We're trying to find b, right? B is what we want to find. B is the height. And do we know c? What is c? Now, if you know the Pythag, but you're not clear what a, b, and c are, c is the distance from the center to the focus points, the foci. That's what C is. So how far is it from the center here to the focus point? It's 64. So now we can solve that equation for B, and B is our height. So use your calculator. 136 squared is a big number. This is 18,496 minus b squared. 64 squared, 4096. Trying to solve here, let's subtract 18,496. And this cancels. Then I get minus b squared. I'm getting minus 14,400. Divide by the -1. It cancels out the negative. B squared is positive 14,400. Last step, root it. B equals Oops, I hit the wrong button on my calculator. I'm getting 120. 120 is the height of the ceiling at the center. That's what B is on the diagram. B, so remember in an ellipse equation, A is how far right and left from the center. B is how far up and down from the center. So how far up from the center, B, the height of that ceiling. When they make that Whispering Gallery, they've got to make the height, and there's the answer. And they want meters. They want you to give all the units in this were in meters. So they want you to say 120. B is 120. The height of the ceiling is 120 meters at the center.